Okay, so we're going to talk a little bit more about how we change an improper fraction into a mixed number. So here's our improper fraction, and again, we know it's improper because the top number is bigger than the bottom number. Okay, that's how you can tell if it's improper. And to get it into a mixed number, I'm just going to do long division. So I'm going to take 37 and I'm going to divide it by 5. So how many times does 5 go into 37? Well, 5 goes into 37 7 times with a remainder of 2. Okay, now if you don't remember how to get that, 5 times 37 is 35, and that leaves us with 2 left over, so that's our remainder. Okay, so 37 fifths is equal to 7 plus 2 fifths. Okay, or we can write it as 7 and 2 fifths is the mixed number version, but it means 7 plus 2 fifths. So if you were to do 37 fifths, you would have 7 wholes and then 2 fifths left over. So now see how that works for rational functions. So I'm going to take this rational function here, and notice the degree of the top is bigger than the degree of the bottom. So to write this as a mixed rational function, what I'm going to do is I'm going to do my polynomial long division. So I got x squared plus 5x plus 7 in here, and then I'm going to divide it by x plus 2. So it might have been a while since you've done this, so let's kind of go through it. So the first step is to see what do I have to multiply this x term by to get an x squared term. And that's simple, it's just going to be an x. Okay, so then what I do is I actually multiply this whole thing by x. So let's do that over here. X times x plus 2. Okay, distribute that. You're going to get x squared plus 2x. Okay, that is what I'm going to put right here. X squared plus 2x. And then I'm going to subtract this whole thing from this thing and see what I get. So when I subtract x squared and x squared, I get 0. Okay, when I do 5x minus 2x, I get 3x. Okay, remember we're subtracting the whole thing, so even though that's a positive 2, if it helps distribute the negative so you don't make any mistakes, 5 and negative 2 make 3. Okay, now we're ready to drop the 7 down, and I go back to my first step in the cycle. I want to times x by something to get 3x. So that would be a 3. Okay, so let's now multiply 3 by x plus 2 and see what you get. So 3 times x plus 2. If I distribute that, 3 times x is going to be 3x. 3 times 2 is going to be 6. So 3x plus 6. I'm going to put that right here. 3x plus 6. And now I'm going to subtract that from 3x plus 7. So 3x minus 3x is gone. It's 0x. 7 minus 6 is 1. Okay, so I have a remainder of 1 when I do my division here. Okay, so now writing this as the mixed rational function is basically the same idea as doing our mixed number here. We take our quotient and our remainder and our divisor and write them like that. So this rational function here is going to equal x plus 3, okay, coming from my answer to my division problem, plus a remainder of 1 out of x plus 2. Okay, x plus 2 because that's what I'm dividing by, 1 because that's my remainder I got when I did my division, and x plus 3 because that's my quotient from my division problem. Okay, so let's check this out by graphing it. So if this really is equal, then this function should give me the same graph as this function. Okay, so here I've got them both written down, ready to graph. So let's first look at this function here, x squared plus 5x plus 7 over x plus 2 was the original. And this is the graph it gives us. Okay, and then x plus 3 plus 1 over x plus 2 gives me this graph. And look at that, they're the same graph. Okay, so these are in fact equal to each other. So that means that I was able to take this improper rational function here and turn it into a mixed rational function here. And again, we call it mixed because it's a mix of a polynomial, like x plus 3 is just a true polynomial in and of itself, plus a ratio or rational function, a ratio of polynomials. And so just like a rational number can be written as an improper fraction or as a mix of a whole number and a fraction, rational functions can be written as a mix of polynomials and rational functions. So let's review what we did. We just took the two polynomials here and here. We'll call this one a of x and this one b of x. Okay, we divided them to get the quotient q of x and a remainder r of x. The remainder function, which is 1. And so we can say that a of x over b of x, which is what we have here, is equal to q of x plus r over b of x. So again, that fits our example that we did with rational numbers that we get here. So you just have to remember what we do with rational numbers, and doing it with rational functions is essentially the same thing, this idea right here. Okay, so take a divided by b, figure out what your quotient is, figure out what your remainder is, and then just your b right there.